Integration Services is Microsoft's premier tool for performing ETL, which stands for Extract, Transform, and Load. ETL processes. Even if you don't know it by that name, you've probably performed these processes if you've worked with databases for any length of time. Extract means pulling data from a source. Integration Services provides drivers and configurations for many types of data sources. Integration Services data sources, data source views, and connection managers are the components you'll use to connect to and extract from various data sources. A single Integration Services package might extract data from many different sources. And then Transform refers to manipulating the data along the way from source to destination. With Integration Services, you'll be able to modify your data in a lot of different ways. The transformation stage can be as simple as copying columns from one table to another as the data moves from point A to point B. Or it can be more involved, including removing duplicates, substituting values from lookup tables, changing the casing of strings, and other forms of data cleansing. Control flow tasks, a specific kind of a task, as well as data flow transformations, are the components that you'll use to work with the data as it moves from source to destination. And then load refers to inserting the data into a destination. As with extraction, Integration Services provides drivers for many common destination types. Integration Services data sources, data source views, and connection managers, again, are the components they use to connect to and load into data destinations. So you can see there's a lot of symmetry between the components and how you use them to access and then store data. Now, although you can use Integration Services to help you load data from external sources into a relational store, a data warehouse, or an analysis services cube, you don't have to use it for that purpose. In fact, an Integration Services package doesn't need to have any data flow operations at all to move data from one place to another. Some people use Integration Services to automate database maintenance tasks, manage files, and even collect system management data by using control flow tasks. An Integration Services solution consists of one or more Integration Services packages. And a package is roughly analogous to an executable file generated by other Visual Studio project types. A package consists of a workflow and business logic that define the operations the package performs upon execution to move and transform data. You define the various tasks that the package needs to perform, linking the tasks together with precedence constraints that determine the order in which the tasks execute and what to do when something goes wrong, such as data of an invalid type that enters the flow, based on the rules that you define within the package. Now, when saved to the file system, a package is stored in a DTSX file that is just an XML file that defines the package and its components. So this shows the XML for a newly created empty package, displayed as an XML file within one of the Visual Studio editors. When you add components to the package, the Integration Services Designer adds potentially large amounts of XML to define those components. Fortunately, you'll rarely have to work directly with this XML. So even understanding its structure isn't necessary to become proficient with Integration Services. And this is really the last time that this course is going to show it. But it's always good to have a basic understanding of the underlying plumbing behind a technology, and Microsoft documents well the structure of this XML. Now, a typical Integration Services package consists of a control flow, some number of data flows, connection managers, and configuration elements. Each part of the Integration Services package is critical to the overall functioning of the package, and I'm going to briefly cover the most important ones in upcoming sections. You'll learn much more about each of these components throughout this course. The first component that I want to talk about is control flows. Control flows are the building blocks of an Integration Services package. They contain the procedural logic that dictates the flow of execution through a package and typically contain tasks, precedent constraints, and containers. Every package that you create will have a single control flow that has at least one task. And a complex package may have hundreds of tasks, all linked together by one or more precedence constraints, with containers that let you organize the package in various kinds of units. Now, tasks are the discrete steps that the package follows from source to destination, including data flows, file management, and scripting abilities. You can think of a task as a single unit of work, although the work a single task might perform might actually be pretty complicated. Tasks are analogous to the methods of a software program that define a set of actions that the program performs. Integration services includes many kinds of tasks right out of the box, including a few that I'm going to talk about now that are the tasks that you'll probably use most often in a typical package. First one that I've already mentioned several times is the data flow task. This is the control flow task that invokes the runtime data engine, providing the core ETL functionality to move and process data. You're likely to have multiple data flow tasks in any non-trivial packages. To create a data flow task, you'll normally specify a source component that provides input data from some table or a flat file or whatever. And then define one or more optional transformation tasks that process the data in the flow in some way. And then a destination component that specifies where you want the output data to be stored. So a lot of times you'll create a data flow task that itself has three components: the source, a transformation, and you might have many transformations, and a destination. But you can have multiple instances of each of those kinds of components. Then there's the execute package task. This lets you execute one package from another, which makes it possible to compartmentalize package functionality and reuse packages. The execute SQL task executes a stored procedure or custom SQL statements, which is very handy for working with data in various ways from relational databases. File system task handles file and folder operations, like creating and renaming objects. The FTP task is really handy because it lets the package send or receive files via FTP to or from remote sites. This is a great way to automatically retrieve flat files, for example, that you want to upload to a database table. You can retrieve them from, say, remote offices or remote plants or whatever. The script task is one of the most powerful tasks that you can include in a package. It lets you write custom .NET code to perform just about anything you can do with the .NET framework. It uses Visual Studio to provide a rich development environment. And then the last one I want to mention is the send mail task. This does just what its name says. This is handy for sending an email when a package completes execution or when something goes wrong. It can be a cry for help to a system administrator. There are many other control flow tasks available that you'll learn about in this course, including some database administration sorts of tasks that let you copy and move databases as well as perform maintenance tasks. And if you can't find a built-in task that does what you need, a script task is extremely helpful in those kind of cases, but it's not reusable across packages. Then you can also create your own reusable custom tasks. There are also many third-party custom tasks available, so it may be worthwhile to do a web search for the kind of functionality that you need. All right, the next component I want to talk about is precedence constraints. Precedence constraints determine the order of operations through the control flow, as well as allow the flow to branch based on success or failure of a task. They link tasks together and determine the overall workflow that you define within your package. A constraint controls the execution of a subsequent task based on the final state of the preceding task and the rules that you define for the workflow. The rules are based on expressions, which let you control the workflow using just about any conditions that you care to define. A control flow has three kinds of precedence constraints available. The first one is success. In this case, the subsequent task is going to execute only if the prior task executed successfully. These constraints are green within the control flow designer. Then there's the completion constraint. In this case, the subsequent task will execute only if the prior task completes, whether it succeeds or fails. And then these constraints are colored blue. And then there's a failure constraint. In this case, the subsequent task is going to execute only if the prior task fails to complete for whatever reason. Typically, you'll use this constraint to provide some kind of notification, maybe an email to a system administrator, that something went wrong. These constraints are appropriately colored red in the designer. A single task can have multiple subsequent tasks, so you can define separate tasks that execute whether the task succeeds, completes, or fails. And with the ability to write code to implement the logic for any of the constraint types, you have enormous control over the package's workflow. Another component that you use within control flows is containers. Containers let you build a package in units, providing looping and sequence operations, as well as making it easier to group related tasks together in a complex control flow. A container provides visual grouping of tasks, as well as lets you define variables and event handlers just for the tasks it contains, using the container as the scope for those other objects. Containers help you give structure to control flow tasks. Now, there are three broad purposes for control flow containers. The first is that you can use a container to repeat tasks for each element in various kinds of collections, such as files in a folder or tables in a database. Or you can repeat tasks until an expression evaluates to false, such as check for new files in a specific folder until noon each day. And then the third one is that you can group tasks that have to succeed or fail as a unit, such as to perform data operations on a table and roll back the entire set of operations if one of them fails. So, for those three purposes, Integration Services provides three kinds of containers. And you'll find these three within the Integration Services toolbox within the Designer environment. First one is the for loop container. This container lets you execute one or more tasks repeatedly as long as a condition that you define by an expression returns true. And this is real similar to how loops work in various programming languages. Each time the loop repeats, it evaluates the expression. The container uses an optional initialization expression that assigns values to loop counters, an evaluation expression used to test whether to continue repeating, and an optional iteration expression that changes the value of a loop counter, usually by incrementing or decrementing it. Then there's a for each loop container. This container executes one or more tasks for every object in the collection. Again, similarly to how for each loops work in various programming languages. This lets you perform tasks for each row in an ADO.NET record set, for example, for each file in a folder, for each item or object in a variable, and various other kinds of collections. And then the third container is a sequence container. This container lets you group tasks into control flows as a subset of the entire control flow. A sequence container can contain both tasks and other containers. If it contains more than one task, you link them using precedence constraints to determine the workflow, again within that container. This lets you do things like disable tasks as a group, manage common properties on the entire set of tasks, make for easier task management, and define a transaction on all tasks within that container. Okay, so those are the three kinds of containers that are available within the Integration Services toolbox. But there's actually one other container, which is called the task host container, and you won't find it in the toolbox. This is an abstract container that encapsulates each individual task in a control flow and provides services to that task. This isn't something that you need to explicitly include. Instead, Integration Services provides it for you, and you don't need to worry about configuring it. When you change properties on a task, you may be working with a task host container, but unless you have a deep understanding of Integration Services, you'll probably never notice. Now, there are various other parts of Integration Services architecture that you'll learn in this course, including things like connection managers that define data sources and destinations, variables that contain state information values at various scopes throughout a package, parameters that provide a way to externally change how a package executes based on various parameter values, as well as error handling and logging features. You can build very simple packages that read data from one source and copy it to a destination, an almost overly trivial use of integration services. But as you learn all that integration services can do, you're likely to create complex solutions with dozens of packages to modularize the data operations to move data from many sources to one or more destinations. The overall solution may take a while to run, but integration services can handle it all, automating most steps while letting you write code to handle the weird or the custom kinds of cases.